Mourad Sultan Ezouidi, the mathematics teacher, the researcher in the fields of polynomials. Okay, today our target is to work on polynomial to the power 6, means that we are going to solve a polynomial to the power 6. Okay, that consists of 0 or 6 roots. Okay, other complex numbers or real numbers, whatsoever, let's say the roots. So today we are going to give you a new method, okay, of Mr. Mourad Sultan Ezouidi, okay, and we will try to solve this polynomial, okay. Of course, we will use the discriminant formula of Mourad, okay. I will share my screen first, okay, entire, okay, screen. Then I should share also my audio system, okay. Therefore, now learners, I will see, okay, okay, I will, okay. So now I shared this one. So now learners, we can see that, okay, I don't have my phone, my daughter. Okay, you can go to mom and see it. I don't have now, okay? Thank you. So therefore, you can see this is a formula of Mr. Mourad Sultan Ezouidi. It's written as SH Ezouidi Mourad. S is Sultan. H is the name of my mother. And this is me, Ezouidi Mourad Sultan, equal the sum that k from 0 to p minus 1, a combination p choose k times between parentheses L0 of all the q, p minus raised to the power p minus k, all between parentheses minus 1 raised to the power p minus k n to the power k L0 of all the q raised to the power k plus S0 of S0 raised to the power k equals, this is for me very important. Okay, one day I'm going to explain this. Also, this one leads also with solving polynomial to the power n. Okay, but today I'm going to fix the roots of this polynomial p of x. This is my polynomial, okay. This is the polynomial that I'm going to solve it, okay. Okay, write this first. Yeah, yes, okay. This polynomial is written as x raised to the power 6 minus 12x to the power 5 plus 2185 divided by the square of 6 multiplied by x to the power 5 minus 35,760 divided by 6 cubed times x to the power 3 plus let's say 332,754 divided by 6 raised to the power 4 times the square of x minus 1,668,528 over 6 raised to the power 5 times x plus, let's say 3,520 and 1,000, of course, 800 over 6 to the power 6 equals 0. So the target here, learners, is to solve this polynomial to the power 6. Okay, in fact, it's not easy to solve this kind of polynomials, but I really reach the fact that whatsoever the polynomial that will be raised to the power 4, 5, 6, and so on, we can solve it, okay, without difficulties. Okay, okay, I'll see this one first. Okay. Therefore, learners, it's an occasion for you to start working on this polynomial to the power 6, okay? Let's say this polynomial, it's very, 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 how to say it, very delicious for me, okay? I'll just, okay, plus you can take my phone and go there and play, okay? So now, learners, p of x, in fact, is written as x to the power 6 minus L0 of all the q. L0, learners, is L1 is this number, okay. L2 is the opposite sign of this ratio, okay. L3 is let's say 332,754 over 6, 4, and so on. Therefore, from L minus 1 to L5, it's called the coefficient of this polynomial, AK. Therefore, learners here to start solving this polynomial, learners, we can say the following facts, okay, that we can focus on this polynomial to the power 6. So let's find out the roots of this polynomial. We should, let's say, determine the values of SR of all the Q relatives respectively to LR of all the Q, where R belongs, learns to the set of numbers -1, 1, 0, and 2, 3, and 5. Okay. Here we already, let's say, gave for you the value of LR of all the Q respectively. Okay, they put in order. L0 is 12, L1 is 2185 over 6 square, and so on. Okay. Now, learners, we are going to show you the formula or the discriminant formula of Mr. Mourad Sultan Ezouidi. Okay, and everyone has to use this formula, the discriminant formula. Okay, it's very important, learners. Okay, it helps, let's say, finding the roots, okay, or writing the values of SIQ. Okay, therefore, learners, I will just okay, this one I will it comes back. Okay, I will try to okay, yes, okay, Control A, then size, full size, Mr. Mourad. Okay, good man. Therefore, now I can do it like that. This is the formula of Mourad Sultan Ezouidi. We are going to set, let's say, k equals 0, then k equals 1, k equals 2, then k equals 3, then k equals 4, till we reach the last k, which is 6 minus 1, which is 5. Okay. Now for k equals 0, we write, learners, this factor k, the value of s minus 1, it's by convention is going to be, let's say, is going to be equal to 1. Okay, you can use the formula. So r started from 0 and to 0 with combination n minus r. Okay, choose r, n raised to the power r times minus L0 for the q to the power negative r. Okay, L r minus 1 over the q. This one, learners, is in fact equal or labeled or named s minus 1 over r is 1. Okay. Now we proceed, learners, to continue. We should, let's say, find the value of A0 of r when k equal what, learners? Equal 1. Okay, I will go to my formula, the discriminant formula of Mr. Mourad Sultan Ezouidi. I will just substitute k for k equal 1. It will be s1 minus 1 is 0. That's why here it's labeled or written or indexed as 0 of r, equal the sum from 0 to 1, combination n minus r, 1 minus r, n raised to the power r times, let's say, minus L0 of all the q raised to the power 1 minus r times L r minus 1 of all the q. Of course, here I will try to maximize. I will try to maximize the page. Okay, if it is possible. Okay, so I comes here. Or okay, zoom. Okay, another. Okay, and again. Okay, again. Okay, okay, Mr. Mourad. So here, learners, we can say that I will just substitute k equal 1. I will obtain combination n choose 1 and raised to the power 0 times minus L0 of all the q raised to the power 1 times L minus 1 of all the q. This is 1 you need to write, but I should appear in the formula. Okay. Ayub, please close the door, Ayub. Okay. Okay. So therefore, I will just, after simplifying, I will just comes to this fact that minus combination n choose 1 times L0 of all the q plus n times L0 of all the q. I'll just close yes, the door. Okay. Therefore, you can see that L0 of all the q, it's call it common factor. I will put it outside the parentheses. It will be n minus ny, n minus 1, n minus n, because this is negative combination, and choose 1 is n here plus n. So it remains the value of S0 is in fact equal to 0. Now I will just substitute. I will write S0 of all the r, okay, is minus 1 over 6 times 12, because this is 12. I will use the last formula. Okay, plus 6 times 12 is negative 72, plus 72 equals 0. Okay, for this case, we found the 0 of r is 0. Now we are going to set, let's say, k equal 2 to find, let's say, S1 of order Q, okay? Here, learners, it's okay, very important to for you to use this discriminant formula. Okay, I will just make this big. Okay, I will just come here, Mr. Mourad. Okay. Yes, okay, no problem. I'll just, okay. Therefore, when k equal 2, so it will be S1, k minus 1, k is 2, it will be S1 of r equal the sum from 0 to 2, combination n minus r, 2 minus r, n raised to the power r times minus L0 of order q raised to the power 2 minus r times L, r minus 1 of order q. This formula, just let's say distributing, let's say the value of r, okay, you will obtain combination n choose 2 times L0 of order q, okay, because 2 minus 0 it will be 2, okay, then n raised to the power 0 is 1, no need to write it here, minus when n r equal 1, it will be combination n minus 1, choose 2 minus 1 is 1, that's why he wrote cn minus 1, 1 times L0 of order q, 2 minus 1 is 2, that's why it's written here 1, times when r equal 1, 1 minus 1 is 0, that's why we wrote it here, learners, L0 for the q, plus what, learners, plus n squared times L1 of the q. You can see that this one is called L0 of the q raised to the power 2, like that, so it's called common factor. I should put it outside the brackets. I want to simplify this, okay, as possible, as soon as possible. I will put this with all the outside the brackets will be L0 q squared times, say, 2n, okay, minus n1 and minus 1, plus the square of n times L1 of all the q. This one learned after calculation. You can see this is, in fact, is 1 times combination n choose 2 times L0 of all the q squared plus n square L1. This formula, learners, you already, it's a new fact that is a discriminant, okay, for any quadratic equation, and also for any point to the power n when, let's say, setting k equal 2, okay, and n varies between, let's say, 2 and more, okay. Therefore, now, learners, I will just make substitution and use my calculator, okay, to figure out the value of this, okay. And here, so I will use this coefficient of my polynomial to the power 6, learners, okay, okay, because it's very important for you to know how can we calculate it, okay. Therefore, I will come here to continue calculating the value of S1. You can see that the value of S1, learners, is negative combination 1 choose 1 is 1 times combination 6 to choose 2, which is 15, times 12 square plus 6 square times 2185 over 6 square. I'll just write it here, learners, negative 15, okay, because this is 15 and this is negative sign, times the square of 12 is 144, 12 square, okay, plus you can see that 6 squared divided by 6 squared, it will be cancelled out. I will just make plus 2100 plus 2185, okay. Then I will try to find the value of this, which is equal to 25, okay. So the value of S1, learners, is equal to 25. Okay, I will close this parenthesis. Okay, after finishing finding the value of S1 and S0, I will try to find the value of, let's say, uh, S2. Okay, for to find, let's say, the value of S2 learners, you should set K equal 0 so that you can evaluate the value of S2. Therefore, I would just come here and I should, let's say, put K equal what learns equal 2 equal 3. Therefore, the formula will be written as S2 of R equal from R from 0 to 3, combination N minus R, 3 minus R, N raised to the power 3 times minus L0 of order 3 minus R, L R minus 1 of order Q. So this one learners, everyone can now use and comes to this fact. Okay, this is called the discriminant formula of Mourad Sultan Ezouidi that helps, let's say, learners, teachers, and professors, okay, even, let's say, logarithms to find the value of S1 up to 6, okay. Okay, so I will just write when r equals 0, it will be 3 minus 0, it will be 3 here, and minus 0 is n, so minus combination, and choose 3 times, n raised to the power 0 is 1, no need to write it here, times minus L0 of all the 3 minus 0, it will be negative, L0 of all the q to the power 3, but the negative sign, I written it in front of this term. Then when n equal 1, it will be n minus 1, okay. 3 minus 1, it will be 2. Okay, then n raised to the power 1. So that's why I should write it as plus n c combination n minus 1 choose 2 times L0 of all the q. 3 minus 1 is 2 times L of all the q. Therefore, 1 minus 1 is 0. So okay, minus when n equal to learners, just you are going to substitute n minus 2, 3 minus 2 is 1, so it will be negative c1 n minus 1, the square of n times L0 for the q times L1 for the q plus, when now n equal 3, it will be 3 minus 3, n minus 3, you can see combination, n minus 3 choose 0, so is 1, that's why he is not written, okay, it's 1 in fact, okay, so therefore, okay, therefore n raised to the power 3, this one it will be 1, okay, and this one is going to be 2, so it will be n cubed L2. Now learners just continue, let's say, explaining the value of, explaining to find the value of S2 using the discriminant formula of Mr. Mourad Sultan Ezouidi. Okay, after, let's say, simplifying, you can note that L0 of order q raised to the power 3, okay, it's common factor, I'll put outside the brackets, then I should simplify as possible, of course, if it is possible, a negative combination, choose 3 plus n combination n minus 1, choose 2, okay, I will put this into parentheses, okay, times L0 for the q raised to the power 3 because it's common factor, minus combination n minus 2 choose 1 n squared L0 for the q L1 for the q plus n cubed L2. Therefore, this one, the first term that is written inside the brackets, okay, it's a combination, let's say 2 choose 1, which is written as 2 times combination n choose 3 times L0 for the q raised to the power 3 minus combination n minus 1 choose 1 times the square of n, L0 for the q, L1 over the q plus n cubed, L2 over the q. Now, I'll just calculate this, learners, okay. I will use this one, okay, to calculate it, to, let's say, substitute for L0, L1, and L2, it's their own values, okay, in the formula, okay. I'm going to continue explaining, okay. Therefore, here you can, let's say, okay, you can, okay, I'll just use this one. I will use the formula now. I will use my calculator. Okay, I will use this. You can see this one is 2 times 20, it will be 40, okay, times 12 raised to the power 3 times 12 raised to the power 3, okay, minus learners 4, combination 4 choose 1, times 12 times 2185 plus learners what plus ik plus 6 cubed divided by 6 cubed. This will be cancelled out. Also 6 squared and here 6 squared will be cancelled out. I'll just write the last answer. Plus what learners? Plus 335,760. This one should be equal, in fact, to 0. Okay, so the value of S2 learners now is, let's say, is calculated and the value is 0. Okay, now we continue proceeding to find what learners, to find the value of S3 means you are going to set K equal 4 to find S3. Okay, therefore I will just substitute S3 of order R is from 0 to 4, combination n minus R, 4 minus R, n raised to the power R times minus L0 of order Q raised to the power 4 minus R times L R minus 1 of order Q. So after this, after let's say finding or simplifying this sum, I would obtain exactly a combination n choose 4 L0 of order 4 minus n c n minus 1 choose 3 times L0 of order Q cubed times L0 of order Q. This one learns its common factor. I will put them here. Okay, it will be L0 of order Q raised to the power 4 times c n choose 4 minus n minus 1 choose 3. Okay, then plus what? Plus when n equal, let's say r equal 2, it will be combination n minus 2 choose 2, the square of n, the square of L0 of order Q times L1 minus when n equal 3, it will be written as 4 minus 3 is 1, n minus 3 means combination n minus 3 choose 1, n cubed L0 of order Q raised to the power 1 times L2 of order Q plus n raised to the power 4 times L3 of Q. Okay, we told that there is a common factor here. Okay, I'll just comes here. This common factor and what is written inside the brackets, in fact, is equal to negative third times combination n choose 4 times L0 of order Q raised to the power 4 plus combination n minus 2 choose 2 and square 0 of order Q square times L1 ik minus combination n minus 3 choose 1 n cubed L0 of order Q, L2 of order Q, and the last term is plus n raised to the power 4 times L3 of order Q. Now learners, this is the formula after simplifying, okay, and setting, let's say, k equal 4, we obtain the last one. Now we should find the value of it, okay, so that we can find its own value. So this one, the formula learners, I'll just use with color green, okay, this one is better. Now I'll come here, I will use my calculator, okay, and then I'll come exactly to continue calculating. Therefore, okay, therefore I will just start from here. Negative 3 multiplied by 50 multiplied by 12 to the power 4. I'll just write negative 3 multiplied by what, Mr. Mourad? By 50. Okay, multiplied by 12 raised to the power 4. Good man, yes. Plus what? Plus 6. Combination 4 choose 2 is 6 times, you see this one, 6 square, and need to write them, okay, they will be simplified, it's called common factor, okay, multiply by 12 squared, okay, multiply by 2185, minus learners what exactly, minus 3 times 12 times 35,760 and 6 cubed divided by 6 cubed is is 1. Now we try them. It will be negative 3 times 12, okay, times 35,760. Okay, plus what learns? Okay, plus 6 raised to the power 4 times 332,754 divided by 6 raised to the power 4. This and that is 1. I'll just write the last term. Plus what learns? Plus 332,754. Then I should make equal sign. So this one learns the value of, let's say, S4 had been calculated. Okay, so it will be 114. Now I will close this. Okay, now it remains to find S4 and S5 so that we can solve our polynomial to the power 6. Okay, I'll just see. Okay, good man. Now set k equal 5. Okay, shall we obtain this fact? Okay. Now, learners, we can say, okay, to think of the value of to find or to try to find the value of S4. Therefore, learners, okay, therefore, learners, it's easy, okay, now to obtain the value of S4. I'll just write here S4 equal the sum started or begins at 0 and ends at 5, combination n minus r, 5 minus r times n raised to the power r times minus 0 of the q raised to the power 5 minus r l r minus 1 over the q. This formula, it's called the discriminant formula of Mourad, Sultan, Ezouidi. Okay, and this formula had been discovered after, let's say, 14 years of work. Okay, yes, after 14 years of work, we got this formula, and also I made its a proof in other book, and I let's say published this book. Okay, whatsoever. Now we continue. We thought that when r equals 0, it will be combination n choose 5. Okay, and 0 of order 5 plus when n equal 1, it will be n raised to the power 1, combination n minus 1 choose 4 times L0 of all the q, 5 minus 1 is 4 times L0 of all the q. You can see this one, in fact, is a common factor between these two terms. We'll see how can we simplify after, let's say, then minus combination n minus 2, choose 3 times the square of n L0 of all the q raised to the power 3 times L1 of all the q plus n minus 3, choose 2 n cubed L0 of all the q raised to the power 2 times L2 minus combination n minus 4, choose 1. Okay, because r is 4 n minus 4, then 5 minus 4 is 1, n raised to the power 4 L0 of all the q raised to the power 1 times the value of L3 over the q plus when n equals 5, it will be combination n choose n minus 5, choose 0. Okay, because 5 minus 5, I get 0, so this one is 1. Okay, so no need to write it here. Plus n raised to the power 5 times L4 of all the q. After simplifying, let's say, these two terms that is written in the beginning, you can see that L0 for the q is common factor times negative combination n choose 5 times plus n times combination n minus 1 choose 4. Okay, this term learns is written as combination 4 choose 1 times combination n choose 5 times L0 of all the q raised to the power 5, the first term, this one. Then minus combination n minus 3, choose 3, okay, times n squared times L0 of all the q raised to the power 3 times L1. Then plus combination n minus 3, choose 2, times n cubed times L3, L0 of all the q raised to the power 2 times L2 of all the q. Then minus combination n minus 4, choose 1, n raised to the power 4 times L0 for the q times L3 plus n raised to the power 5 L4 of all the q. I will use the coefficient of the polynomial to the power 6 to figure out the value of S4. So let's see the value of S4, learners. Okay, I will try to make it bigger for you. Okay, like that, Mr. Mourad. Okay, this is S4. I'll see. I got a notification. Okay, I don't know from where the notification. Maybe Facebook. Okay, now I will erase this one. I will start from this. Okay, so it will be clear for you. Sorry. Okay, I will start from this first. We have a combination. This is 24. I will write 24 times 12 raised to the power 5. Okay, 5. Yes, Mr. Murat. Then minus combination 4 times 12 cubed times this one. This 6 squared divided by 6 squared. No need to write it. Minus 4, I will write, times 12. Okay. Raised to the power 3. Okay. Times learns 2185. Then plus 3 times 12 squared times 35,760. Then I will just write plus 3 times learns 12 square. I will write 12 square. No problem, is 144. But I will write it as that, 35,760. Okay, times. Then minus combination 2, choose 1 is 2. I will write minus 2. Okay, times 12. Okay, times Mr. Mourad, times 12. Times 6 raised to the power 4, 6 raised to the power 4, they will be cancelled automatically, and also this automatically be cancelled. So with all that, minus 2, okay, times 12 times 300 times 332,754. Then plus 6 raised to the power 5 divided by 6 raised to the power 5. No need to write it. It will be cancelled out. So we'll just write 1,668,528. Then plus positive sign plus 1,686,528. This one, learners, I will make equal sign. So the value of this is 4 is in fact equal to 0. Okay, therefore I will close now this window, okay, to continue finding the value of okay of of 5. Okay, now to find the S5R, you should set k equals 6 in the formula, in the discriminant formula of Mr. Mourad Sultan Ezouidi. Okay, then I will just comes down if it is possible. Okay, stuff like it. Okay, now I will yes, I'll make the gray color. This one learns okay, this value of LR for the Q, respectively, of course. Okay. Now learners, we told that we should, let's say, distribute K for the in the discriminant formula of Mr. Mourad. Okay, we can find that S5 is the sum from 0 to 6, combination n minus r, 6 minus r, n raised to the power r times minus L0 for the q, 6 minus r times LR minus 1 for the q. After calculation, learners, it will be combination n choose 6, L0 for the q raised to the power 6 minus n combination n minus 1, 5, choose 5, L0 for the q to the power 5 times L0 for the q. You can notice, you can make some notes. You can see that this one and that, it's called the common factor, plus a combination n minus 2 choose 4 n squared L0 for the q raised to the power 4 times L1 over the q minus combination n minus 3 choose 3 n cubed L0 for the q cubed times L2 for the q plus combination n minus 4 choose 2 n raised to the power 4 L0 for the q squared L3 for the q minus learners with all that combination n minus 5, okay, because r is 5, When r is 5, it will be n minus 5. 6 minus 5 is 1. Okay. N raised to the power 5 because r is 5 minus L0 of ODQ. 6 minus 5 is 1. That's why the negative sign is appeared in front of the expression. Plus what learns? Okay, I will make here, I will make it bigger for you. Okay, I'll make this is down to appear. Okay, good man. Okay, therefore, okay, Mr. Mourad, go back, Mr. Mourad, come there, Mr. Mourad, enter. Okay, okay, ارجع هكا. Okay, no problem. I'll come back, 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 back. Okay, I will cut this. Help. Now, as I cut this, I will, okay, go back. Now, okay, now it's okay, it's done. Therefore, we told that plus negative combination n minus 5 choose 1 and raised to the power 5 and therefore the q raised to the power 1 times 4q plus 1 n equals 6. 6 minus 6 is 0. Combination n minus 6 choose 0, say 1. So that's why no need to write it. N cubed, n to the power 6, r is 6. L6 minus 1 is 5. It will be L5 for the cube. We thought this one, learners, it's this one and that have a common factor. These two terms, I should put this common factor outside the brackets, either written in on the right hand side or on the left hand side. So here it's written on the right hand side times this combination, this value. This value, learners, it's in fact equal to negative combination 5 choose 1 times 6 choose 6, so is 1. Okay, that's why here we wrote 5 choose 1 and 0 for the q to the power 6. Plus, of course, the other simple calculation, n squared, okay, okay, n squared for n minus 2. I put n squared here. Okay, this one 6 is, n is 6 now because pulling to the power 6. 4 minus 2 is 4. 4 choose 4 is 1. That's why here no need to write 1. Okay, plus minus n minus 3 choose 3 and 6. 3 minus 3 is 6 minus 3 is 6. Sorry, 6 minus 3 is 3. Choose 3 is 1. That's why we wrote 1. Okay, no need to write it even. I just write negative the cube of n. The cube of 0 for the q times L2 plus this one also is 1 simply because 6 minus 4 is 2. 2 choose 2 is 1. Then times n raised to the power 4, the square of 0 for the q times L3. Then this one also learns is 1 is 1. Okay, n raised to the power 5. Okay, 0 for the q raised to the power 1 times L4 plus the last term when let's say r equal 6, it will be combination okay, it will be n minus 6 or 6 minus 6 is 0, so plus term written 1 times n raised to the power 6 times L5 over HQ. After that, we just focus on the last formula, this one. I should find the value of this and I should figure out the value of S5. Now learners comes here, okay, to find the value of this. Okay, I'll comes here, learners, we told. Okay, I'll try to put here, okay, no problem. Okay, I will reduce this one if it is possible. Okay, or I will open like that. Okay, now learners, I should use my calculator. Every one of you can use his own calculator to figure out the value of S5. Okay, here learners, this is my calculator. I will start from the left hand side. This is the 0. Okay, we told that negative 5 times 12. Okay, negative 5, Mr. Mourad, times 12 raised to the power 6. Okay, good man. Then plus, you see 6 squared divided by 6 squared. No need I'll just write plus 12 raised to the power 4 times 2185. Therefore, plus 12 raised to the power 6, okay, raised to the power 4, Mr. Mourad, multiply by 2185. Then you see negative 6 cubed divided by 6 cubed. Now I need to write it. Then I will just write negative 12 cubed times 35,706. I'll make minus negative sign. I will make 12 raised to the power k3, okay, times learns 35,760. Then plus 6 raised to the power 4 times 12 raised to the power 2 times 332,754 over 6 raised to the power 4. This 6 and this 6 becomes now I'll just write the square of 12 times this one. Okay, plus 12 square, okay, square, times learns 332,754. Then minus 6 raised to the power 5 times 12 times 1,668,528 divided by 6,5. This 6,5 and this 6,5, no need to write it because the value of it is 1. Okay, I'll just write 668,528. Good man. Then plus, you see this one, 6 raised to the power 5, 6 divided by 6 raised to the power 6. No need to write it, I'll just write plus last value, plus learns 3, okay, 3,520 means 3,520,800. This one learners, I can just check, okay, 800, 523. This one learners should be equal to 0. And now the value of the S5 is now, okay, now I finished this part. Okay, now learners, I will try to replace in the new polynomial that I will get, okay, relative of course to S0, S1, S2, S3, S4 to continue solving my equation. Okay. Okay, therefore here okay, I will just, in other words, we calculated S0, S2, S4, S5. Okay, all of them are equal to 0 except S1 about R is 25 and S3 of odd R is 114. I will use the method, okay, okay. Therefore, our comes here learners. So any polynomial to the power 6 after calculating the value of S1, S2, S3, S4 has to be written as the following. P of x, okay, this one, P of x, I will make with the with wonderful color. I will see which one. Okay, this one is better. Color of the sky. I love the color of the sky. So learns, okay, we can see that the new polynomial raised to the power 6 is x to the power 6 minus, in fact is written as that, but we negligate, we no need to write this one, but I will explain this for you. This is minus 1 of r. We told that is the beginning is 1, so no need to write it. Okay, learners, okay, x raised to the power 6 minus s0 of order r x raised to the power 5 plus s1 of order r x raised to the power 4 minus s2 of order r x cubed plus s3 of order r the square of x minus s4 of order r x raised to the power 1 plus s5. Okay, I will just write this as that, okay, because all the let's say this value, this SR of all the Q are 0 except S1 and S3. I will just simplify this as P of x equal x raised to the power 6 plus S1, x raised to the power 4 plus S3, x raised to the power 2. You can see that x2 is a common factor. Okay, I put here x2 is a common factor. Okay, I will put outside the brackets. Okay, so that I can simplify after. Okay, times x raised to the power 4 plus s1 raised to the x raised to the power 2 plus s3. If you are going to expand, you will got this one. Okay, x2 x4 is x6, then x2 s1 x2 is x1 x4, then x2 s3 is s3 x2. Okay, therefore, this one equals 0 or this equals 0. Okay, I'll just continue learning this. Let's write P of x equal x raised to the power 6 plus s1 raised x raised to the power 4 plus s3 of order r x raised to the power equals 0, means this one is equal 0, or that is equal 0, meaning that x squared is 0, or x raised to the power 4 plus s1 x squared plus s3 equals 0. There we continue learners finding the value of this. I should first find the discriminant. Okay, formula when n equals 4. Okay, what is it? Okay, we told here, what is it exactly? Okay, we told that, okay, this is, yes, here we told that x squared equals 0, meaning that the value of x where k belongs to 0, 1 is 0. Therefore, the roots of the first two roots of my polynomial to the power 6, the original polynomial I mean, okay, is L0 for the cube plus xk belongs to 0, 1, which is 12 plus 0 divided by 6 gives 2. Okay, this is the first value. We have double root here. Okay, okay, then okay, x is to the raised to the power 4 plus s1 x squared plus 3 plus s3 is x to the power 4 plus, I will substitute s1 with 21 and s3 with 114 because we find them in the beginning. Then the discriminant formula of Mr. Mourad Sultan Ezouidi, okay, when n equal to, it will be s1 of all the r dash equal negative s1 of all the r raised to the 2 plus raised to the power 2 plus 4 times s3 of all the r. Just calculation to be negative. Okay, it will be negative. I will just use my calculator. It will be learns. Okay, 0. It will be negative 25 square plus 4 times 114. Okay, 14 is that, yes. Okay, we told that negative 25 squared plus 4, 114. This one is equal, learners, negative 169. So negative 169, which is equal to negative 13 square. Therefore, minus the discriminant formula of Mr. Mourad Sultan Ezouidi S1 R dash, it will be 13 square. It's a square number. Therefore, now I can go to continue solving the value. Okay. So we just write x square is equal to negative s1, okay, plus root of s1 of all the r dash, okay, divide by 2 because we have two roots, x is to the power 4, okay, means you can make x squared all raised to the power 2, okay, okay. Therefore, I will write negative 25, okay, because S1 is 25, negative 25 plus root of 13 divided by 2, 13 squared, of course. You can see that 13 squared is 13. I will write negative 25 plus 13 divided by 2 is negative 4. Therefore, x squared is negative 4, means that you should find two complex roots for this polynomial to the power 6. I will just write this as, okay, I'll just write down if it is possible. I will write x, if let's say x squared equal negative 4, therefore x k belongs to 0, 1 is the root of negative 4 exponential ik pi. Why exponential ik pi? Because in fact it's 2 exponential ik pi. Then it should be divided by 2 because root, okay, divide by 2 gives only ik pi. Then you see minus 4, I can write minus as exponential I pi, you see, and root of 4 is 2, and minus 1, I will write it as exponential I pi. Then root of exponential I pi will give you, learners, exponential I pi over 2. Okay, you have the same base, okay, different indices. You should add multiplication to be 2 exponential 2k plus 1 parentheses I pi over 2. Therefore, this is the roots of x squared, the roots of the new polynomial that I got under the S0, S1, S2, S3, S4, S5. Therefore, now the roots, the two roots is alpha k belongs to 0, 1 is L0 of all the q plus xk. Of course, this is 1 only, not 2. Okay, which is 12 plus what, learners? Plus 2 times this one over 6. Okay, clear? Okay, this also 2 complex numbers. So, therefore, now I finished solving this equation. Okay. Okay, now we got, let's say, 4 roots, 2 complex numbers, and 2 real numbers. It remains now the last one, x squared equal minus s1 over the r minus the root of s1 r dash divided by 2, because here you can see this one, learners. Okay, I make it a different color if it is possible. Okay, like that. Okay, you see this one, the last one, before we made minus plus. Okay, this one here. You see this one now? No, only the first one, I mean. This one minus s1 of r plus, okay, because we have 2 roots, x raised to the power 4, and here x raised to the power 2. Let's say, or let u equal x squared, and you are going to do like that. Okay, therefore, we told that, jury, please. So x squared is minus s1 of r minus root of s1 r dash divided by 2. It will be negative 45 minus 13 squared. Root, of course, divided by 2. It will be negative 45, negative 13. It will be negative 38 divided by 2 is negative 19, which is negative number, means that we get 2 other complex number. So therefore, minus 19 exponential ik pi, I will just put minus 1 as exponential I pi inside the square root. Then I will just make exponential I pi over 2, because it is written inside the square root. It will be only 9 root of 19 exponential 2k plus 1 I pi over 2. This is the roots of the two roots, roots of my polynomial to the power 6. And now the roots of the original polynomial alpha k01 is L0 of all the q, okay, x plus the value of xk that belongs k to 0 to 1 over 6, which is 12 plus root of 19 exponential raised to the power 2k plus 1 I pi over 2 k over 6. Okay, so this one, these are called the solution. Okay, now if we are going to consider the first 2 real roots, okay, we thought that is 2. We are going back to our equation, okay, and we should substitute alpha equal 2, and you will check that is really it's a double root for this polynomial to the power 6, okay. Therefore, learners, I'll come as here, okay, yes, okay, I thought yes, okay. Now I'm going to check if 2 is a root, okay. I'll erase this. This is, learners, you can see that. I will put where exactly, okay. Now I will start like that. I will make 2 to the power 6, 2 to the power 6, raised to the power 6, Okay, minus 12 multiply by 2 raised to the power 5. Okay. Plus, between parentheses, boys, I will make, okay, I will make 2185 divided by 36, which is 6 square, and make 6 square, 6 square. I will close the parentheses, multiply by what learns? Multiply by 2, okay, raised to the power 4, okay. Then I finish this one. I will come as, okay, to this. Then minus, okay, between parentheses, it's better. It will be 35760 divided, Mr. Mourad, by 6 raised to the power 4. Okay, close the parentheses. Times Mr. Mourad, okay, 2 to the power 3 is 8, okay, plus, okay, plus, okay, plus, okay, plus this one now, it will be plus, okay, between parentheses, of course, 332754 divided by 6 raised to the power 4. Good man. Close this parenthesis. Okay, times what? Times the square of 2 is 4. Then minus, between parentheses, learners, 1,686,528 divided, of course, by 6 raised to the power 5. Good man. Close this parenthesis, Mr. Mourad. Times 2 equal, okay, equal, okay, we thought we make minus, huh? Okay, 3, okay, sorry, okay, minus 1 and minus 1668, okay, with 65 times 2, يساوي equal, just make it plus for the plus any number, plus 0, equal, and here we have just make copy هذه multiply, okay, equal خلاص equal 0 multiply by 6 raised to the power 6, okay, raised to the power 6, okay, just a moment, I will just do it again. By the way, first, by the way, in general, we obtained the 6 roots, okay. So don't forget to use the formula of Mr. Mourad Sultan Ezouidi. Really, it helps you to find all the 0. Okay, so inshallah we see you next time. Okay, working with the solving point to the power 5. You can also check it by yourself. You will get the now the 0 for when x equal 2 and the other roots. Thank you for listening and goodbye. Okay, now we'll end the screen. Okay. Connection. Mr. Mourad. To end the stream, I wish that the explanation and the demonstration for finding the